Okay, so let's talk about ionic properties. These are properties of ionic compounds. First of all, ionic compounds are made up of those positive and negative ions, like we've talked about. And the positive ions don't want to be next to another positive ion. The negative ion don't want to be next to another negative ion. And so we get this alternating structure. And so it's really the ions then being arranged in a repeating three-dimensional structure that we call a crystal lattice. So as you can see in the pictures here, we have our alternating kind of red and green representing the different ions that we have here. And then again, it's going to be kind of this rigid solid structure in this case. The attraction between those oppositely charged ions is really very strong, which causes many of the properties of ionic compounds like a high melting point. And so we can see here, and I'll show a little video here, but we can see here that the melting point of salt and the melting point of sugar are very different. So sugar is a covalent compound. Salt, again, NaCl, is an ionic compound. And so you'll see here they put just a little bit into the pan. Hopefully we'll see that here in a second. And then they will heat it up. And again, we'll just be able to see that they really are going to melt at different rates. And so they kind of speed up the video here. So here you can see that our sugar has started to melt. It's actually started to burn a little bit then too, but our salt has definitely not started to melt at all. If we think about another property, or if we think about some of our other properties, we can really compare from one type of compound to the next. And so we have our ionic compounds, our covalent, and metallic. And remember, in our last unit, we talked about covalent and metallic. And so, again, let's think first of all about how they're formed. Ionic compounds are formed by having that transfer of electrons. So again, sodium has its one valence electron here. It will transfer the electron to chlorine so that sodium becomes a +1 ion and chlorine becomes a -1 ion. So those electrons are transferred, the ions are created, and the oppositely charged ions attract each other. This is going to happen anytime we have a metal and a nonmetal, a metal and a polyatomic ion and a nonmetal, or two polyatomic ions. Covalent compounds, on the other hand, are the sharing of electrons. So we have those that overlap there, and the electrons are shared between the two atoms. This is happening between two nonmetals. And then finally, we have our metallic. And remember, we talked about that sea of electrons in our last unit where many atoms share many electrons, and we get kind of this free flow of electrons. This is going to happen between metal atoms, so two different metals. If we have the same metal, that would just be an elemental metal, for example, like silver, or we could have different metals, and that's considered an alloy. If we compare these three types of compounds then, ionic will be solids at room temperature. They have very high forces of attraction between the particles. Covalent, some are solids, but they tend to be kind of those softer solids, but most are liquids and gases, especially gases. Metallic, those are mostly solids, with mercury really being the only exception that is a liquid. If we think about, again, some of our other properties, we can talk about melting point. Ionic compounds are very high in their melting point, meaning, salt is about 800 Celsius. And so, anything kind of 500 and above is considered pretty high in its melting point. Water, boils normally at room or at 100 degrees Celsius. So just to give you an idea there. Covalent are low melting points, and then metallic are very high melting points again. So think about those solid metals that we interact with all the time. We use them on our stove. We don't want our pots and pans melting on the stove when we heat them up. Hardness, ionic compounds are hard. Covalent are low hardness or very soft. And metallic, it varies. We do have some softer metals and some very hard metals. Brittleness. Ionic compounds will shatter, and the reason they shatter is because if we start to shift things, we get those two positive ions next to each other, and then they repel, and so they tend to be very brittle. Covalent compounds are not brittle. They will deform, not shatter. And again, metallic compounds have low brittleness. They are very malleable. They will bend without breaking. Ionic compounds are very highly soluble in water, meaning they will easily dissolve in water. If I take salt and I put it in water, it will easily dissolve. Covalent compounds, on the other hand, are usually very low. So things like waxes and oils do not dissolve in water. And metallic compounds also do not dissolve in water. Electrical conductivity. So ionic compounds, yes, they are good conductors of electricity, but only in certain situations. So they will dissolve, if they are dissolved or melted, the charged particles, those ions, can move around, and that will allow them to conduct electricity. But the charged particles have to be able to move around. So they will not conduct electricity in their solid form. We have to have them dissolved or melted. Another word for melted would be molten. So sometimes we talk about molten lava. And so that's melted lava or melted rock. Covalent, no, those will not be conductive in solution. They do not have any charged parts, so they will not be conductive. But metals, again, metals are good conductors of electricity because those electrons can freely move around. So examples of these different things, ionic, include things like sodium chloride, that's our top picture there, and copper sulfate, that's the bottom picture there. You can see they have these nice crystalline structures. Those are because of their crystal lattice, that regular repeating pattern. Covalent compounds include things like wax and rubber and sugar. Many of them come from also a lot of natural sources also, just like we find some of our crystals. But again, these are all things that again are low melting points and are pretty soft in terms of their solid structure. And then finally, we have our metals there: iron, bronze, we can see also, which is an alloy of copper, tin, and zinc.